Hi students, today we are going to discuss some topic related to number system, and previous videos we already discussed some like some animated videos related to this and some explained videos related to this. Okay, so today we are going to discuss the topic from number system, which is real numbers and their decimal expansion. Okay, so as what exactly I'm able to tell you, I was able to like explain you in the last classes related to the rational numbers and irrational numbers and what are real numbers, and we know, as we know, that real numbers, in real numbers we have natural numbers, whole numbers, integers, and rational and irrational, all inclusively. Correct. Anyway, I did the video based on this. So all in a set will form a real numbers. What are those? Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So inclusively, a set of all these numbers systems will form a real number system or real numbers. Correct. So now what basically we are going to discuss is about the decimal expansions. So what are these decimal expansions? So why we need it, and what is the different thing in this decimal expansion? So you might have, like in 8th, or in 8th standard, maybe you studied this in 4th or 3rd standards also, how to divide a number. So how to divide it when you are getting a decimal point also, right? So that is not a new thing to you. So the new thing is what kind of expansion. So let me explain this. So you guys, some people might be knowing it, some people might not be knowing it. Anyway, some videos is done related to this. So, but one thing you have to be clear: the decimal expansion, okay, may stop whenever you divide. The division will stop. Sometimes division will not stop. Sometimes division will repeat, means numbers, quotients will be repeating. So these are the like consequences. So these are the things which you face when you divide a number, correct? When you divide a number with the other number. So let me take one example. What is this? Find the decimal expansions of 10 by 3, 7 by 8, and 1 by 3. So let me divide 10 with 3. Okay? Let me divide 10 with 3. So what do you get? 3. 3 threes are 9, right? So 1. Correct? So definitely you cannot solve directly. So take one decimal point, put one decimal point, it will become 0. So 3 threes are 9. Again you will get 1. So put 0. Okay. Take 3 threes are 9. Correct. Again you will get, what is it? 0 here you take 10. 3 threes are 9 you take. So it keeps on repeating. Correct. 3 point, again 3, 3, 3, 3. So where it will end? It will never end. If you keep on dividing, you will keep on getting the same quotient. 3.333. And remainder became 0? No. Remainder is continuing. Okay. Now let me do one more division. First 7.8. So how to divide 7 with 8? Okay. So whenever you divide 7 with 8, obviously we cannot divide 7 with 8 because 7 is the number less than 8. So we cannot divide. Correct. So take 0 point. Correct. So you'll get 8 is a 64, right? 8 9 is a 72. So we cannot take. So 70 minus 64, which will give you 6, right? So already you put the decimal point, you can write 0. No need to put one more decimal point again, right? So our 8, our decimal points are even 0. So 8, how many times 8 sevens are 56. So again you will get 4. So again decimal point this way, you put 0, 8 5s are 40. In this, for this decimal division, you got 0 as the remainder. Correct? Got 0 as the remainder. So we stop at the division, and there is nothing called continuation like this. Correct? So we stop the division. The next we will go with the next division, which is 1 by 3. So 1 by 3, how can we divide? So 3 you take. Again, obviously, 1 is lesser than 3. So take 0 point. Correct? So 10, 3 threes are 9. Correct? isn't it? So 3 threes are 9. I think you just take it as 1 by 7 because 1 by 3 is same as 10 by 3. Take with 7, it will be easy. So because with 7 only you will get the, like decimal, because 10 by 3 you will get the same also, 0.33 like that. So if you take 7, 7 ones are 7. Okay, 7 ones are 7, 10 minus 7 is 3. Correct? So next, take 0, 7 fours are 28. So again you get 2, isn't it? Next, 1, 4 again, take 0, 7 twos are 14, either 7 threes are 21, so we cannot take. And next again, take 0, 7 eights are 56, correct? So which will give you 4, correct? Because 7 nines are you cannot take, 63. So 40, you'll get 7 fours are 28. Again, you'll get how much? 40 minus 28, that is 2, 12, isn't it? 3 minus 2 is 1, and 10 minus 8 is 2. So 12 you will get, correct? Again, what you get? 1, 12 in the sense you should take, okay, 7 ones are 7 only, isn't it? 7 ones are 7 or 8, yeah. I think here, yeah, that's correct. So you just go with 7 ones of 7, which will give you 5. So this division keep on continuing. So 4 again, you will get 50. See here, 50 you are getting. It means 7. How many times? 7 fours are 7. Okay, 7 sevens are. So it keeps on continuing. So we cannot continue this. So what we can observe here, the division is never getting stopped. Correct. And remainder is getting stopped. No, remainder is also not getting stopped. Means you are not getting remainder is 0 also. Okay, 7. Yeah, you are getting not getting 0 also. So what we can do for this? So main thing you have to understand in these 3 different expansions. One expansion you see you are not getting, you got remainder is 1. Everywhere you see for the first expansion you are getting remainder as 1. Correct? I hope you understood what I am saying. Okay, fine. 40 I think so we can take 7 fives are. Here we made a mistake. 7 fives are 35 you can take. It is because even we have bigger number, right? 35. After that, 7 6 are 42 you cannot take. So here 40 will get 50. Correct. 40 minus 35 is 50. And next 7 sevens are 49. Okay. 7 sevens are 49. Again you will get 1. It will be keep on repeating. Fine. So yeah. Anyway, 7 0.4 124857. So this division is why I am explaining division, because you have to understand what kind of decimal expansion. So remainder is 1. Everywhere remainder is 1 is correct. Everywhere you observe remainder we got it as 1. Okay, remainder is 1. What about the divisor? Divisor is 3. Anyway, and expansion, quotient if you see, quotient if you observe, you have 3.3333. Same quotient is getting repeated. Same number is getting repeated. Correct? And what is this decimal expansion? In this, remainder became 0. At one particular point, remainder became 0. Quotient is 0.875. In this, nothing is repeated. Correct? So let's stop. We got a perfect quotient. In this case, in this particular division case, if you see, you are getting remainder. What is remainder here? Some value, unknown value. Like not an unknown value, a number which is not even repeated. So here 3, here 6, here 5, here 1. So even remainder also not same. Remainder is different. So you can write remainder is not same. And quotient also not exactly getting stopped. Quotient is some numbers is continuously repeating, not exactly continuously. Some number is repeating and division is not getting stopped. So first case if you see, remainder is same, and especially here repeating we have repeating decimal. And anyway, here division is not getting stopped. So that is the reason it is non-terminating decimal. Okay. Why I am calling it as non-terminating decimal? Because division is not getting stopped. Correct? Understood? Non-terminating, as I said you that terminating in the sense stopping. Correct? Termination means stop. So here it is not stopping. So that's the reason it is called as non-terminating decimal. And this here also division is getting stopped? No. So that is the reason this is considered as non-terminating decimal because the division is not getting stopped. Correct? Non-terminating decimal. Isn't it? Okay. Now, in this case, if you see, division is stopped. So, can I say it as terminating? Terminating decimal. Okay. What is the difference in this three different expansions? In this case, it is non-terminating decimal. There also it is non-terminating decimal. But in the middle one, if you see, it is terminating decimal because division is stopped in this case. Okay. This is terminating decimal. And what is the difference in this and that? This expansion, that expansion. See, some numbers are repeating, or some numbers are as a quotient we are getting, not the same numbers again and again. Here we are getting quotient as same number again and again. It is 3.3333. So this is considered as non-terminating and also repeating decimal. Why it is repeating? Because you are getting a repeated number more times. Same number is repeating, not even different number. Same number is repeating again and again. That's the reason it is also considered as repeating decimal. So I hope you understood. I'll just explain once again. The first expansion, if you see, okay, here if you see the decimal expansion here, we divide 10 with 3, like 3. So we are getting 3.3333. So this is the quotient we got. So and next case we did and we got quotient as 0.875 and here it stopped. Even the division also stopped here. So quotient we got exact quotient value and we got remainder of 0. And the other one we have seen we are not getting remainder same and division also not getting stopped. Correct? Division keeps on continuing. There is no stop in the division. So division also continuing. Okay, continuing in that and it is not getting stopped. It means you are not getting remainder. So in these three cases, what you can observe, the first one and the last one, especially you observe first one and last one. First one, division is like not stopped, correct, as it is not getting stopped. So that is considered as non-terminating decimal. Why? What do you mean by terminating, non-terminating? Terminate, you might be knowing this word called terminate. Terminate in the sense stop. So if the division is stopped, getting stopped here, no. That's the reason it is called as non-terminating decimal. Last one also, division is not getting stopped. So that is also considered as non-terminating decimal. So here, this one if you see, division is getting stopped and we are getting a proper quotient value and the remainder is 0. Correct? So that's why we call it as terminating decimal. So what is the difference between this one and the last expansion is, some numbers you are getting, but in that, see 1, 4, 2, 8, 5, 7, nothing is repeated. All are different numbers. Here if you see 3, 3, 3, same number is getting repeated. So the difference is both are non-terminating decimals only and this decimal is also considered as repeating decimal. It means non-terminating decimal as well as repeating decimal. Okay. So repeating decimal in obviously it should be a non-terminating. When it will repeat, division will get repeated usually. Okay. So that is the reason we are considering this as non-terminating decimal and also as well as we also call as repeating decimal. Okay. I hope you understood these different types of decimal expansion. So what I am going to do is let me do some sums based on this. Okay. Not exactly the same expansion sums, some sums related to your examination. Okay. So yeah. First, let me take one sum. Yeah. Expansion or express them in P by Q form. Express the given numbers, or they will give you some numbers. Express the following in P by Q form. Okay, so first one is 0.6. Okay, 0.6 bar. Anyway, this I didn't not use 0.6 bar. Bar in the sense, just you put one slide, like an arrow kind of thing, not an arrow kind of thing. Just hyphen up on the number 6. It means it is same as 0.6666. So which kind of number it is? It is a repeating decimal. Correct? Repeating decimal expansion as well as it is a non-terminating decimal expansion. So how can you prove that, or how can you write this in P by Q? Remember one thing, students. Any number which can be written in P by Q form is called as rational number. A number which cannot be written in P by Q form is a irrational number. So it means this is a terminating decimal. Sorry, non-terminating decimal and repeating decimal. So this can be written in P by Q form. Remember, non-terminating decimals in the sense especially repeating decimals, and non-terminating decimals means repeating decimals and terminating decimals can be written in P by Q form. Correct? Non-terminating decimals means which are not repeating decimals. In most of the cases, we cannot write them as in P by Q form. Some cases we write, for example, pi is equal to 22/7. Remember, pi is not at all equal to 22%. Exactly not equal. As I told you in the previous videos also, previous sessions, 1 by 2 is 0.5, but pi is not equal to 22/7. Pi is approximately equal to 22/7. Remember that. So, how to convert this into P by Q form? So, 0.6666 we are getting. Let x is equal to 0.666. It keeps on continuing. So put dot dot. Don't stop. You put dot dot. Then only it is considered as repeating decimal. If you put dot now, if you don't put dot, it is considered as a terminated decimal. Okay. So it is x is equal to. Now here, which first thing you have to understand, which digit is repeating? Whether the digit is 2-digit number or 1-digit number, that you have to understand. And we have to check it first. Here, only 6 is repeating. So 6 is what kind of number? Basically, it is 1-digit number. So what I am telling you, if it is 1-digit number, multiply with 10. Understood? When it is 1-digit number, you multiply with 10. So if you multiply 0.666 and so on with 10, okay, you leave 0.6 with 10. If you do what you get, 6 no? Correct? 0.6 into 10 is 6. Why? Because 6 can be done. 6 by 10 and 10 will get cancelled. You will get 6. Easy method. Because 0.6, after the decimal point, you have 1 digit. You can write this as 6 by 10 and you are multiplying with 10 will be cancelled. So, if you multiply 0.6 with 10, you are getting 6. If you multiply 0.666 with 10, you will get 6.666, right? This one decimal point will go, right? So it will become 6.666, and this 666 dot dot will keep on repeating. It will not end. So, yeah. Anyway, you subtract, okay, or you can do like this. 2 minus 1 you do. Okay. First you write second. 10x is equal to 6.666 dot dot. Next, x is equal to 0.6666 dot. Correct. So subtract. When you subtract, what do you get? 10x minus, we are doing subtraction, right? So subtraction means we have to anyway change the signs, and 10x minus x is 9x. Correct. And 6 minus 0 is 6. Correct. 6 minus 0 is 6 before decimal point. After decimal point, you have 6 is everywhere 6. You can write that 6.000. Correct. Any number which is 0.00 means 2.0 or 2 point, after the point you put 10 zeros or 20 zeros, infinite zeros. It is 2 only. Correct. Similarly, you can write 6.000. So x is nothing but 6 by 9. So 3 2s are 3 3s are. So we can also write it as x is equal to 2 by 3. So we expressed 0.6 recurring or 0.6 bar. Correct. 0.6 or repeating decimal 0.666 dot dot in P by Q form, that is 3. Okay. 2 by 3. You check, divide 2 with 3, you will get 3. Okay. 0.666. 20, no? 6 by 80, 20 minus 18. 2, again you take decimal point, like, because of decimal point you can add 0, you get 0.6666 dot dot. So we proved that, or we expressed 0.6 in the form of P by Q. Okay. Let me take one more example or one more sum of the different type. I mean, same, we have to assume them, what is it, expressed in P by Q form only, the sum is different, that's all. Okay. Let me explain one more sum based on the same type. 0.47, okay, 0.47. 0.47, okay, 0.47. So this can be written as 0.47 because recurring is there for both, remember. Okay, you can write like this. Correct. So let x is equal to this. Same thing what we did for the last. Okay, we assumed it as x is equal to. So now what I'm telling, what I told you in the last example or last sum, you just check which number is repeating. Here 47 is repeating, not 6. It is not a one digit number. Remember, 47 is what kind of number it is? 2-digit number. Correct. It is a 2-digit number. When it is 2-digit number, their 1-digit number, that's why you multiply with 10. Here it is 2-digit number, that's why multiply with 100 on both the sides. Okay, that you multiply with 10 because 6 is 1-digit number. Here 47 is 2-digit number. So if it is 2-digit, multiply with 100. For example, if you have something 3-digit repeating, okay, I'll just, it's an example only, 473, 473, 473, like this. If it is repeated, you might have taken 1000 multiplied with 1000 because it's 3-digit number. So depends on the how many digit number is repeating, depends on that. You should multiply with the 100 or it may be 100. If it is 1 digit, it is 10. If it is 2 digit, it is 100. If it is 3 digit, it is 1000. If it is more than 4 digit, 10,000 depends. So here it is 2 digit. So that's the reason I multiplied with 100. So now 100 into x. Yeah, as we know, 0.47 into 100 is what? It is 47. How? 47, 0.47 can be written as 47 by 100. Because after the decimal point, we have 2 digits. So that's why we are dividing with 100. And again, we are multiplying with 100. So you get 47. Similarly, if it is 0.47 dot dot, if you multiply with 100, so what you get? 100x is equal to, okay, this 2 digits will come. Over there you got 1 digit because it is 10. Correct? You got 6.66. Here this 2 digits will come. 47.474747 and so on. Okay. This you take it as equation 2. Okay. This you take it as equation. Now do 2 minus 1. Okay. We are doing 2 minus 1. So 100x is equal to 47.474747. Correct. And here x is equal to 0.474747. Okay. Dot dot. Don't like forget to put dot dot. Correct. So now 100 minus x, which is 99x, and 47 minus 0, 49, and 4 minus 4, 0, 0, 0. See, same numbers subtracted with the same number, definitely you will get 0. So what we got? 99x is equal to, okay, 47.003. Okay. I hope you understood this. So x is equal to, we got 47 divided by 99. Okay, because 47.00, how many times you write 0? That is same as 47. correct? So we got 47 by 99. So this, if you divide 99 with 47, definitely you will get 0.474747 dot dot. Okay, you will get definitely a repeating decimal. Okay, yeah, let me explain this once again. What we assume, we have to express this in the form of P by Q. So, how to represent this 0.47 in P by Q form? And as I told you, you can represent a rational number only in the form of P by Q. You cannot represent irrational number. As I told you guys, for irrational number, you will not get any repeating decimal. Okay, we just did know the third part of decimal expansion, so that will be almost like that. So x is equal to what I am assuming, that x is equal to 0.474747 and dot dot, and here as I told you 47 is repeating, only 47 is repeating. So 47 is a two-digit number, so multiply with 100 on both the sides. Okay, both the sides you multiply with 100. When you multiply with 100 on both the sides, so 100x is equal to, it will become 47 into 47 will come here, because 0.47 into 100 is 47. Similarly, we can write 0.47 as 47 by 100, correct? Into 100. Already we have into 100. We can write 47 as 47 by 100. 100 will cancel. You will get 47. So similarly, if you multiply the 100, these two digits will come before the, okay, decimal point. So which is 47.474747. Don't say after the decimal point, you should call it as 47 only. You cannot call after the decimal point. It will be, some people I see, like I observed saying 2.30, 2.45, 2.38. This is wrong. You have to say, if any digit after the decimal point, you should say it as 30. You should say in the number form. Don't say in what is it, words like 30, 400, 300. Completely wrong. You should say it as 2.30. Okay. So here, when you subtracting second 2 minus 100, so 100x minus 47.4747, and x is equal to 0.474747. So subtract, you will get 99x is equal to, and here 47 minus 0, 47, and you will get 474747. That obviously same number subtracted with the same number, you will get 0. You got 99x is equal to 47.000. See, 2.00 is same as 2 points from 10 zeros or 47 points. 100 zeros you put, that is 47. So 99x is equal to 47. So x is equal to 47 by 99. So we proved, or we have shown 0.47 in the form of P by Q. I hope I made you understood. Okay, and this are like important sums. Okay, and you have to focus on this. Okay, I hope I made you understood, guys, and these sessions are, I'm thinking that these sessions are helping you a lot. Okay, thank you very much. And please comment, share, like, and subscribe. Please support us by subscribing and tapping the bell button. Have a fantastic day for you guys.